October 1941. Winchester Repeating Arms Company, New Haven, Connecticut. On the factory floor, David Marshall Williams watched as military inspectors rejected his rifle design for the third time. Too light, they said. Too simple. Not powerful enough for real combat. The Army wanted heavy, expensive weapons. Williams had created something else entirely. A 7-pound carbine that could be manufactured for $15. 18 months later, that rejected rifle would become the most produced small arm in American military history. Over 6 million units. And in the jungles of the Pacific, Japanese soldiers would learn to fear its distinctive crack above all other sounds. This is the story of the M1 Carbine. Not the famous M1 Garand rifle that General Patton called the greatest battle implement ever devised, but its smaller, lighter cousin, the weapon the Army didn't want. The M1 Carbine was designed for soldiers who weren't supposed to fight: radio operators, truck drivers, mortar crews, officers, support personnel who needed protection but couldn't carry a full-size rifle while doing their jobs. Official War Department records show that by 1945, the M1 Carbine had become the second most common weapon in American service. It armed paratroopers at Normandy. It cleared caves on Iwo Jima. It became the preferred weapon of Marine raiders and Army scouts across the Pacific. This is how a simple design, rejected by military procurement officers and built by factory workers using mass production techniques, transformed American infantry tactics and saved countless lives in the war's most brutal combat zones. The story begins not in 1941, but in 1938. Army Ordnance Department studies, declassified in 1973, identified a critical problem. Roughly 60% of soldiers in a typical infantry division never fired a rifle in combat. They operated radios, drove vehicles, maintained equipment, and carried supplies. These support troops carried the standard M1 Garand rifle. It weighed 9.5 pounds. With ammunition, bayonet, and field gear, a radio operator or vehicle driver carried over 50 pounds of equipment while trying to perform technical duties. Lieutenant Colonel Rene Studler of the Ordnance Department wrote in a September 1938 memorandum, now archived at the National Archives, "The current armament system fails to adequately protect support personnel. These soldiers require a weapon light enough to not interfere with their primary duties, yet effective enough to provide personal defense." The Army issued a formal requirement in June 1940. Create a light rifle weighing under 6 pounds, effective to 300 yards, and costing no more than $20 to manufacture. 8 major firearms manufacturers submitted designs. Winchester Repeating Arms submitted a proposal based on patents from David Marshall Williams, a former convict who had designed weapons while serving time in a North Carolina prison for murder. Williams, born in Cumberland County, North Carolina in 1900, had been convicted in 1921 for his role in a deputy sheriff's death during a raid on his illegal distillery. While imprisoned, he worked in the prison workshop and developed the short-stroke gas piston system that would become the heart of the M1 Carbine. His design used a revolutionary operating system. Instead of the long-stroke piston used in most military rifles, Williams created a short-stroke piston that tapped gas from the barrel just long enough to cycle the action. This reduced weight, simplified manufacturing, and increased reliability. In September 1941, after multiple rejections and redesigns, the Winchester design was finally approved for production as the U.S. Carbine Caliber .30 M1. The Army wanted 100,000 carbines delivered within 6 months. Winchester alone could not meet this demand. In October 1941, the War Department made an unprecedented decision documented in Ordnance Department files. 10 different manufacturers would produce the M1. Carbine, using shared specifications and interchangeable parts. Winchester, General Motors, IBM, Standard Products, National Postal Meter, Quality Hardware, Rock-Ola Company, Underwood Typewriter, Saginaw Steering Gear, and Irwin-Pedersen. This consortium included companies that had never manufactured firearms. Rock-Ola made jukeboxes. IBM made typewriters and punch card machines. Underwood made office equipment. The challenge was immense. Traditional rifle manufacturing required skilled gunsmiths hand-fitting components. The M1 Carbine needed to be assembled by factory workers with minimal firearms experience, using parts made by companies across the country. Winchester's chief engineer, Edwin Pugsley, led the standardization effort. His team created detailed manufacturing specifications for every component, measured to thousandths of an inch. These specifications, preserved in the Winchester archives at the Buffalo Bill Center of the West, allowed any manufacturer to produce parts that would fit any carbine. The simplified design proved crucial. The M1 Carbine used stamped metal parts where traditional rifles used machined steel. The stock was made from inexpensive hardwood instead of carefully selected walnut. The sights were simple and durable rather than precision adjustable. Production records from the War Production Board show the results. By June 1942, 8 months after approval, manufacturers had delivered 100,000 carbines. By December 1943, production reached 100,000 units per month. The final production cost, according to War Department procurement records, between $14 and $17 per unit, depending on the manufacturer. This compared to $32 for the M1 Garand and $45 for the Thompson submachine gun. Factory workers, many of them women who entered the workforce during the war, assembled the weapons. At the Saginaw Steering Gear Division of General Motors, workers who had built automobile steering columns now assembled carbine receivers and barrels. Oral histories collected by the Rosie the Riveter Trust include testimony from Mary Kowalski, who worked at Saginaw Steering Gear from 1942 to 1945. In a 1988 interview, she recalled, "We made 400,000 carbines. I worked on the barrel assembly line. We were told every weapon we made would save an American soldier's life. That gave us pride in the work. Quality control was rigorous. Each carbine underwent proof testing with high-pressure ammunition to ensure the barrel and receiver could withstand combat stress. Random samples were fired thousands of times to verify reliability. Weapons that failed inspection were disassembled and their parts recycled." By war's end, official production figures documented in the War Department's Industrial Mobilization for War report total 6,332,000 M1 carbines manufactured. This exceeded the production of any other small arm in American history. The first M1 carbines reached combat units in the summer of 1942. Official Army Ground Forces reports from July 1942 document the initial distribution. Carbines were issued to officers, non-commissioned officers, radio operators, vehicle drivers, and weapons crew members. The expectation was that these soldiers would use the carbine for personal defense only. The .30 carbine cartridge used a 110-grain bullet traveling at 1,990 feet per second. This produced significantly less power than the .3006 rifle cartridge used in the M1 Garand or the .45 CP pistol cartridge used in the Thompson submachine gun. Ordnance Department testing, documented in technical reports archived at the Army Heritage and Education Center, showed the .30 carbine was effective against personnel targets out to 300 yards. However, it lacked the penetration to defeat heavy clothing, wooden barriers, or light armor at longer ranges. Early combat reports from North Africa in late 1942 were mixed. After-action reports from the 1st Infantry Division noted that officers and radiomen appreciated the carbine's lightweight during long marches across desert terrain. However, some soldiers questioned the cartridge's stopping power in close-quarters combat. A February 1943 report from the 1st Armored Division stated, "The M1 Carbine has proven satisfactory for its intended purpose. Tank commanders and vehicle drivers report the weapon does not interfere with their duties and provides adequate protection against enemy infantry at typical engagement ranges of 100 to 200 yards. The weapon's true test would come in the Pacific theater, where combat conditions differ drastically from North Africa and Europe." August 1942. Guadalcanal, Solomon Islands. The 1st Marine Division landed with limited numbers of M1 carbines, primarily issued to officers and headquarters personnel. Combat in the dense jungle would reveal both the weapon's capabilities and its limitations. After-action reports from the Guadalcanal campaign, declassified in 1968, provide detailed feedback from Marines who used the carbine in combat. The terrain was unlike anything American forces had encountered. Triple canopy jungle, where visibility rarely exceeded 50 yards, steep ridges, and thick vegetation that made carrying a 9-pound rifle while climbing exhausting. Major General Alexander Vandegrift, commanding the 1st Marine Division, noted in his post-campaign report archived in the Marine Corps' Historical Division, "The M1 Carbine proved ideally suited to jungle warfare. Its lightweight allowed Marines to move quickly through difficult terrain. Engagement ranges in jungle combat rarely exceeded 100 yards, well within the carbine's effective range." Marines reported the carbine's advantages: rapid aimed fire, lightweight for jungle movement, reliability in humid conditions, and adequate stopping power at typical jungle engagement ranges. However, the carbine revealed limitations. The 15-round magazine emptied quickly in firefights. The .30 carbine cartridge lacked penetration against palm logs and other jungle cover. Some Marines reported malfunctions when the weapon became clogged with mud and debris. Technical reports from ordnance officers on Guadalcanal identified specific issues. The carbine's gas piston system, while reliable in clean conditions, required regular cleaning to function in the mud and humidity of jungle combat. Marines learned to field strip and clean their carbines daily, sometimes multiple times per day. Despite these limitations, demand for the carbine increased. Marines who carried the lightweight weapon in jungle patrols reported significantly less fatigue compared to carrying the M1 Garand. The carbine's semi-automatic fire provided a critical advantage over bolt-action rifles in close-range jungle ambushes. Combat experience from Guadalcanal and subsequent Pacific campaigns generated consistent feedback. The 15-round magazine was inadequate for sustained firefights. In response, the Ordnance Department contracted with several manufacturers to develop a 30-round magazine. Engineering drawings and test reports from 1943, archived at the Springfield Armory National Historic Site, show multiple prototype designs were evaluated. The challenge was mechanical, creating a reliable magazine that could feed 30 rounds of ammunition without jamming, while remaining durable enough for combat conditions. Early prototypes suffered from feed failures when fully loaded due to excessive spring pressure. By mid-1944, a refined 30-round magazine entered production. Field testing with the 1st Marine Division on Palaeo in September 1944 confirmed the improved magazine's reliability. After-action reports noted, the 30-round magazine significantly improved the carbine's effectiveness in sustained engagements. Marines report increased confidence in the weapon's ability to provide suppressive fire. Production records show that by early 1945, 30-round magazines were standard issue for Pacific combat units. The increased ammunition capacity transformed the carbine from a defensive weapon into an effective tool for offensive operations. The M1 Carbine found unexpected success with airborne forces. Paratroopers faced unique challenges. They jumped carrying all their equipment, landed in hostile territory, and needed to fight immediately after landing. The standard M1 Garand rifle, with its weight and length, proved cumbersome for parachute operations. The 82nd and 101st Airborne Divisions began receiving M1 carbines in late 1943 during preparations for the Normandy invasion. Official training reports from Fort Bragg, archived in the 82nd Airborne Division records, document extensive testing of the carbine with parachute equipment. The carbine's light weight reduced the total load carried by paratroopers. Its folding stock variant, the M1A1 Carbine, was specifically designed for airborne use. This version, with a folding metal stock, could be strapped to a paratrooper's side during the jump and deployed immediately after landing. On D-Day, June 6, 1944, thousands of paratroopers jumped into Normandy carrying M1 carbines. After-action reports from the 101st Airborne Division note, the M1 Carbine proved highly effective in the confused fighting immediately following the drop. Paratroopers engaged enemy forces at close range in hedgerows and villages where the carbines, lightweight and rapid fire, provided significant advantages. Similar reports came from Operation Market Garden in September 1944 and the Rhine crossings in March 1945. Airborne commanders consistently praised the carbine as ideally suited to paratrooper requirements. The M1 Carbine reached its full potential in the island-hopping campaigns of 1944 and 1945. On Saipan, Guam, Peleliu, Iwo Jima, and Okinawa, Marines and Army infantry faced Japanese defenders fighting from caves, bunkers, and fortified positions. Combat ranges were extremely close, often under 50 yards. After-action reports from these campaigns, compiled in the War Department's Specific Theaters of Operations reports, show increasing reliance on the M1 Carbine for cave clearing and close-quarters combat. A March 1945 report from the 3rd Marine Division on Iwo Jima stated, "The M1 Carbine has become the preferred weapon for cave and bunker assault teams. Its lightweight allows Marines to carry additional grenades and demolition charges. The 30-round magazine provides sustained fire during assault." Marines report the weapon's reliability even after exposure to volcanic ash and sand. Captain John Sweeney, a Marine Company commander on Iwo Jima, wrote in a letter to his family in April 1945, later donated to the National Museum of the Pacific War, "Our carbines never failed us. In the caves, you need a weapon you can swing around quickly. The carbine was perfect. Light, fast, and it kept firing no matter how much ash got in it." Japanese combat reports, captured and translated after the war, reveal enemy respect for the M1 Carbine. A February 1945 document from Japanese forces on Iwo Jima, archived in the War Department's Japanese monograph series, noted, "American troops armed with the light automatic rifle demonstrate high rates of fire in close combat. This weapon proves particularly effective in cave assault operations." The carbine's effectiveness in Pacific combat led to changes in official doctrine. By early 1945, Army and Marine infantry companies in the Pacific were authorized significantly more carbines than the original distribution plans. Some Marine rifle companies carried carbines for 70% of their personnel, rather than the originally intended 30%. Statistical analysis from War Department casualty reports, while incomplete, suggested units with higher carbine distribution experienced fewer casualties in jungle and island combat. The correlation was strong enough that Pacific commanders actively requested additional carbine shipments. After Japan's surrender in August 1945, The War Department conducted comprehensive evaluations of weapons effectiveness. The Infantry Board at Fort Benning, Georgia, compiled feedback from thousands of combat veterans between October 1945 and March 1946. These surveys, archived at the Army Heritage and Education Center, provide detailed assessment of the M1 Carbine's performance. Key findings from the Infantry Board's final report, published in April 1946. 89% of soldiers issued the M1 Carbine, rated it satisfactory or better for their assigned role. 73% of carbine users stated they preferred it over the M1 Garand for their specific duties. However, the report also documented limitations. 35% of respondents reported the .30 carbine cartridge lacked adequate stopping power in certain combat situations. Soldiers in the European theater, where engagement ranges were often longer, reported less satisfaction compared to Pacific Theater veterans. The report concluded, the M1 Carbine successfully fulfilled its design purpose. It provided adequate protection for support personnel while allowing them to perform their primary duties. Its lightweight and reliability made it especially effective in jungle and close-quarters combat. Cost analysis from the War Production Board showed the carbine's economic impact. The $15 production cost, combined with massive production volume, meant the United States armed 6 million personnel for less than the cost of equipping 1 million with Thompson submachine guns. This economic efficiency allowed the military to provide semi-automatic weapons to soldiers who otherwise would have carried only pistols or no weapons at all. The M1 Carbine saw extensive use in Korea from 1950 to 1953. Combat reports from the Korean War, archived in the U.S. Army Center of Military History, showed the carbine performed well in the mountainous Korean terrain. Its lightweight proved advantageous during long patrols in steep mountains. However, Korean War veterans also reported significant problems. In the extreme cold of Korean winters, temperatures dropping to 30 below zero, carbine malfunctions increased dramatically. The light .30 carbine cartridge proved inadequate against Chinese and North Korean soldiers wearing heavy quilted winter uniforms. A February 1951 report from the 2nd Infantry Division noted, M1 carbines frequently malfunction in extreme cold conditions. Personnel report, the weapon requires excessive maintenance to remain functional. Multiple hits are required to stop enemy soldiers at close range when they wear heavy winter clothing. Despite these limitations, the carbine remained in service throughout the war. By 1953, however, military planners recognized the need for a more powerful selective fire weapon that could perform both the carbine's role and serve as a frontline infantry rifle. This recognition would eventually lead to development of the M14 rifle and, later, the M16 rifle system. The M1 Carbine's greatest legacy may be manufacturing innovation rather than combat effectiveness. The program demonstrated that complex military weapons could be mass-produced by companies with no firearms experience, using workers with minimal specialized training, and achieve complete parts interchangeability between manufacturers. This manufacturing philosophy, documented in War Production Board histories, influenced post-war military procurement. The principle that weapons should be designed for mass production, using simple manufacturing techniques and interchangeable parts, became standard doctrine. The M16 rifle program in the 1960s, the M4 carbine program in the 1990s, and modern military procurement all reflect lessons learned from M1 carbine production. Design for manufacturability, specify precise tolerances for interchangeability, and distribute production among multiple contractors to ensure supply resilience. The companies that produced carbines during the war also gained manufacturing expertise that shaped post-war American industry. General Motors applied lessons from carbine production to automobile manufacturing. IBM used precision manufacturing techniques developed for carbine parts in computer production. The National Museum of American History preserves an M1 Carbine manufactured by each of the 10 contractors. Examination of these weapons confirms the remarkable achievement. Parts made by Rockola fit perfectly in a carbine made by IBM. A barrel made by Winchester functions flawlessly in a receiver made by Underwood. This level of standardization, achieved in wartime conditions under intense production pressure, represented a milestone in American manufacturing capability. The workers who built these weapons, particularly the women who entered the workforce during the war, played a crucial role in Allied victory. They manufactured 6 million weapons that armed American and Allied forces across 2 oceans. Today, M1 carbines remain popular with collectors and shooters. Hundreds of thousands survive in civilian hands. Shooting competitions specifically for military surplus carbines draw participants across the country. The weapon that military inspectors initially rejected as too simple has become an enduring symbol of American industrial mobilization and practical weapons design. The story of the M1 Carbine is not about individual heroism or dramatic battlefield moments. It is about successful engineering, efficient manufacturing, and practical design meeting specific military needs. David Marshall Williams, the convicted murderer who designed the carbine's operating system, received a pardon from the governor of North Carolina in 1929 based partly on his firearms inventions. He continued designing weapons until his death in 1975, while his short-stroke piston system made the M1 Carbine possible. The weapon's success resulted from the combined efforts of thousands of engineers, factory workers, and soldiers. The factory workers who assembled these weapons, working in plants across America, produced a simple, reliable tool that served its intended purpose. They transformed drawings into functional weapons at a scale unprecedented in firearms history. In the jungles of the Pacific, the weapon that Army inspectors called too light and too simple proved ideally suited to combat conditions. Its light weight allowed Marines to fight in terrain where every pound mattered. Its reliability kept soldiers armed when mud, rain, and coral dust destroyed more complex weapons. The M1 Carbine never achieved the fame of its larger cousin, the M1 Garand. It lacked the Thompson submachine gun's cultural presence. Military historians debate its effectiveness, noting both its successes and limitations. But the numbers tell a clear story. 6.3 million produced, more than any other American small arm, issued to every American military branch. Used in combat from 1942 through the 1960s, still functioning 70 years after manufacture. The weapon was exactly what it was designed to be: adequate protection for soldiers whose primary job was not fighting. A radio operator who survived a Japanese ambush because his 7-pound carbine didn't prevent him from taking cover. A truck driver who held off an enemy patrol long enough for reinforcements to arrive. A paratrooper who cleared a farmhouse in Normandy because he could maneuver quickly with a light weapon. These were not dramatic moments that changed battles. They were individual incidents of survival, multiplied across millions of soldiers, in hundreds of engagements over 4 years of global war. The M1 Carbine represents a fundamental principle of military effectiveness. The best weapon is not necessarily the most powerful, but the one that works reliably when soldiers need it, can be manufactured in sufficient quantities to arm those who need it, and costs little enough that industrial capacity can produce it without straining other war production. Engineers, factory workers, and soldiers proved that simple, practical design could be more valuable than complex, powerful weapons when applied correctly. In the National Archives, production records document 6,332,000 M1 carbines. Manufactured between 1942 and 1945. In combat reports from Guadalcanal to Okinawa, soldiers recorded their experiences with the weapon. In museums across America, surviving examples demonstrate the engineering and manufacturing achievement they represent. The factory workers' $15 rifle became essential equipment for American forces in the Pacific not through dramatic innovation, but through meeting specific needs with appropriate technology, manufactured at sufficient scale and distributed to soldiers who used it effectively within its limitations. That is the complete story, based on documented history, verified through archival sources. No speculation required.